So, hello everyone. Today I will be demonstrating you about the NDVI analysis of Katoria village. So basically, this is our project, and this is the project of Geeks for Geeks. And what we have done the NDVI analysis of Katoria village. Basically, Katoria is situated in Bihar, and it has a controversial land. So before 2016, we were seeing different plots and different less plantation in the Katoria village, but after 2016, we saw a rapid growth in the NDVI index and different farming techniques. So we'll be doing the analysis of that through the FB profit model and normal visualization techniques. So this is the introduction, and our solution was using the Google Earth Engine API, GEE. So basically, we have used the GEE for the analysis of the NDVI values, and we have extracted data from the GEE. So this is the interactive data analysis. So we can see different plots here. So if I choose the index, x-axis as here, and let me choose the line plots. Just 1 second. Yeah. So we can see the general trends here, and likewise there are different plots here. So farmers can use these plots, and if they are able to understand these plots, so they will be able to see the general trends of the individual values. So through this, we can see the data set. It is from 2013 to 2021, in the end of 2021, basically. So these were the insights what we have found from the crop calendar and after the analysis of NDVI values. And we have the forecasting and analysis here. So this is the link basically. So this was the Google Collaboratory. Let's move to the Google Collaboratory and understand what exactly we have done. So we have basically used the GMAP, and we are using the Google Earth Engine, as I said earlier. So Google Earth Engine is basically an API which uses satellite imagery to extract different sort of information. So we have imported and installed different libraries here. So here we have used the different libraries, and we have also authenticated and initialized. And next we have to select the area of interest. So basically I've given the coordinates of Katoria village. So you can see the Katoria village here. And we are using the Landsat satellite. So basically, Landsat satellite is very suitable for detecting forest fire, NDVI values, temperature, and different sort of things. So we are just giving the polygon shape of a land, which is the basically the area of interest. So this is the coordinate. These are the coordinates, and basically we have created a polygon through the entire coordinates. And we are giving the time period from 2013 to 2023, and we're getting total number of images to be 97. So we are plotting the first image in the image collection. So we can see it's the image. So yellow areas are just. Yeah, so we are having different sort of values like red, green, blue. And these are the plotting of the first images. And we are just moving to the Landsat image collection of NDVI. NDVI of every image pixel in the image collection will be calculated by the equation NDVI equals to NIR minus red upon NIR plus red, where NIR is a B5 band and red is the B4 band. Average NDVI and NDVI will be calculated on every images to get the time series of NDVI of the area of interest. So this is the calculation. Basically, satellite uses the reflectance value, and it sends the reflectance ray to the Earth, and these rays are just back to the satellite and from where we are getting the information. So we are having the functions to calculate the NDVI and of every image in the image collection. And this is the function which calculates the mean NDVI. So we will be iterating over every images, and we will be calculating the mean NDVI of every image. And here is a for loop. And in this for loop, what exactly we are doing, that we are iterating over every images, and we are just finding out the mean NDVI value of every image. And from here, we are extracting the dates from the image collection, and we are creating a time series data frame for the NDVI. So we are having 97 rows. And for better analysis, we will be resampling the data monthly through the median. So we can see here. And this resampling, or more, we can see the interpolated data almost fits the original data properly. And now let's move to the data analysis and visualization of raw data. So this is what we have done. We have used the date and NDVI column, and we have the segregated year, month, and day. So this is the NDVI variation with year. So these were the assumptions we can get. The NDVI index has been increased in the post-COVID years. So what we can see from the 2019, these have been increased. And the NDVI index was lowest in 2015, and it had the most outliers. According to the IMD, Bihar witnessed a rainfall deficiency till mid-2015, declaring a drought as the rainfall deficiency increased 28% lower than the average. So this is where we can see these NDVI values are getting reduced, and after that, everything is just getting increased. So NDVI variation with month. So the extracted data doesn't has much information in the month of July. So as we can see here, and in the September, there's a time of flowering of crop, and yellow flowers can decrease the NDVI values. So there's a research paper on the internet from where we got this information that these yellow flowers can increase the NDVI value. So like if we are just using this model, so we have to basically keep this in mind that in the month of September, NDVI values will decrease, but there's not the reason behind this is the flowering of these plants. So June is the hottest month in that region and has the worst NDVI, which means the region is not suitable for summer crops. So likewise, we have different assumptions from this graph, and we have checked the crop health, and these were the certain thresholds from where we decided. So from this, in all these years, most of the crop lies in the unhealthy region, which are basically redwood. And we can see significant amount of crops that are in the moderately healthy region, which are the yellow one. And the crops lying in healthy region are significantly less as crops don't grow over the entire year. So there are specific months which has the higher NDVI index. So from here we can see values ranging from -1 to 0, such as the dead plants. From 0 to 0.33 are unhealthy plants. 0.33 to 0.66 are moderately healthy. Very healthy plants lies from 0.66 to 1. And we have also plotted this graph also, and these were the rainfall reports. So we can see a seasonal trend here from 2013 to 2022. It is not much good, but yeah, we can see some seasonality here. So these trends are almost repeating. So from the above plots, what we can get, these are the following assumptions. The autumn harvest in 2018 was poor in India's eastern province of Bihar, as according to the sources, rainfall was deficient by 25% of its long-term average during the southwest monsoon. And we can see a significant increase in NDVI values in the month of October and November, as it's the peak time of winter crops, and after these crops are harvested. So we can see this from this graph. And from the above plots, we just found out these things. And this is a volume plot, which will suggest the most of the NDVI values are ranging from -2.7 to 0.359, depicting the moderately healthy plants. And the max value of NDVI was recorded as 0.699 and minimum was 0.11. And we also did the visualization and analysis of on interpolated data. And we also found some different changes, and basically it was not as per the raw data. So yeah, so we got some different outputs, and like the outliers from in the 2015 were changed, like the NDVI index in the NDVI index is highest in the year of 2016, and it had the most outliers, whereas the raw data, it was in the year of 2015. And in the monthly interpolated data, the outliers of 2015 were removed. So as you can see from the graph. And now if we move to the monthly analysis, so the NDVI index from January, April is low because most of the crops have been harvested. And the October month doesn't show much change in the interpolated data. So this was the thing which we saw. And the interpolated data shows significant changes as compared to the ADA of the raw data. And similarly, we found the crop health on the monthly interpolated data. So what we found that there is only one point in the monthly interpolated data which shows the most healthy plant. And the reason could be due to the statistical interpolation, which is squeezing the data to monthly. And we found the agriculture harvest in Katoria according to the table, uh, which was recorded in 2017. We can see the area under different harvest showing a good total amount of Katoria region being a controversial land. And on monthly interpolated data, we saw different, and we can see NDVI in the year of 2015. So we have to find the reason for that. And the line plot shows more generalized seasonal trend as per the raw data. And as we can see, the graph post-COVID years show increasing NDVI values. And from the boiling plot, according to the visualization, we can see the interpolated data. Most of the data lies between 0.27 to 0.33, depicting most of the crops are moderately healthy over the time period. And seasonal phase of crop and final month-wise analysis we did. So we were able to find the outcomes for every month: May, June, July, August, September, October, November, December, and January. So we have just written some of the outcomes of every month, and this could be beneficial for the farmers to understand how to just grow their crops and get a better result. And we also read the seasonal decomposition of trend, seasonality, and residuals. And we can see the original data and we can see the trends, and what we can infer that from 2018 the NDVI index has been changed rapidly. We can also see the seasonal trend here. So seasonality is constant over time, but it strictly follows a cyclic manner. That is, every year there are specific times when the NDVI index rises and falls. So for more information, we just took 2 years from 2018 to 2020. We plotted a time series of NDVI decomposition here also. So we can see the similar results. And looking into the seasonality, NDVI hits lowest over fall and winter season, whereas it hits highest in the summer season. This is expected given of the geographical context of Eastern India. So let's move to the NDVI prediction of modeling. We are using the profit model, as ARIMA and Auto ARIMA model are a bit basic models and they will require more tuning. So we have used the FB profit model for the forecasting. So we are just importing the libraries and initializing them. So we are creating every profit model for this forecasting. So we will upsample the date column to daily frequency by interpolating it on daily basis to get increased size of data to get more accurate predictions. And the NDVI values have been linearly interpolated to fill any missing values. So we have just resampled the data. And yeah, here we can see. So this is the interpolated data and it really fits good and with the original data. And we have just made the train test split here. So before 2020, we are having the train data, and after 2020, we are having the test data. So from this graph, you can see. And now going to the main part, renaming the NDVI data frame to DS and Y to be compatible with the every profit model. So we are just setting the index and DS to NDVI and Y respectively. And now we are just importing the every profit model and making it. So we are just setting the daily seasonality equals to false, and we are just doing frequency for day periods. So like for every day, we will be getting the forecast, and we are just forecasting it to the future. And here, so we can see through this graph. So we are just getting a very good accuracy here. So these are the trends, and this is the weekly analysis, and it is the yearly analysis. Now we are just forecasting for from the year 2020 to 2022. So yeah. So this is our final NDVI prediction. So we can see a decent pattern here. So like our predicted graph is almost on the actual graph. So basically we are almost getting a good prediction. So these techniques can be used in real time. So like we were getting some of the outcomes and conclusions from this. So like the epic profit model has captured a decent seasonality pattern, and the main part is actual NDVI data is infrequent, whereas model trains on the basis of daily observations. So more frequent data is expected to improve the prediction. So like if you're getting the more frequent data, so we would be able to get more better predictions. So now we are just going to the model performance. So yeah, we are just calculating the MSE, MAE, and RMSE, and we are also getting the average score. So average score was 0.77162. So these were the summarization which we got from the model. And there were a few areas we have to explore, like applying a cloud removal algorithms to get more frequent data, applying classification algorithm to create vegetation only to mass more accurate and calculate NDVI, looking for a satellite image with shortest revisit time to increase the date training gate volume, and identifying special events that triggered the change in NDVI, such as natural disaster, drought, or forest fire. So this can be included in every profit model for more robust prediction, and error in the prediction can be identified and add as a regressor for every profit prediction. So these were the areas to explore. So basically what we are seeing that we are almost getting a decent trend in the NDVI prediction. So this model can be used in real time by the farmers. So like they can get appropriate information about the upcoming days and they can grow their plants in the right manner. So that's all.